Hi everyone, today we are going to learn how to find rational zeros to help us to find all real zeros of a polynomial function. But before we get started, I have 3 factoring problems I would like you to do. The first one is x squared minus x minus 12. The second one is 2x squared minus 5x minus 3. And the third one is 25x squared minus 36y squared. So please pause the video and factor each of these expressions completely. And when you have an answer, please restart the video and we'll get started with our lesson. All right, let's see how well you did. So the first thing I'm going to do with this trinomial is split it apart into 2 parentheses. Splitting apart the x squared into an x and an x, I need to ask myself what 2 numbers multiply to equal negative 12, but together add to equal negative 1. And that's going to be a negative 4 and a positive 3. So inside of my parentheses, I'm going to have an x minus 4 and an x minus 3, or x plus 3, excuse me. Next, I'm going to break apart this trinomial into 2 parentheses. The only way for me to get a 2x squared is if I have a 2x times an x. Now the nice thing is that the only way for me to get a 3 is with a 3 and a 1, and my goal is to get a negative 5. So I'm going to write out the factors of 3 and 1, and my goal is to get a negative 5. So I need to figure out where I should put my 3 and my 1. So I'm just going to try a couple of things. I know that 2 times 3 is 6. And 1 times 1 is 1, and I know that negative 6 plus 1 is equal to negative 5. So I need my 6 to be negative, so I'm going to have a minus 3 and a plus 1, and that's my factorization. 2x plus 1 times x minus 3. And for number 3, this is considered a dots, a difference of 2 squares. So I'm going to split it apart into 2 parentheses. The square root of 25x squared is 5x, so I have a 5x and a 5x. And the square root of 36 is 6, so I'm going to have a plus 6y and a minus 6y. And that is my answer. Hopefully these factoring problems were very easy for you. If they are not, please make sure that you come and see me as soon as possible so that I can help you with factoring. All right, so for our lesson for today, our learning objective is for you to be able to say, I can use the rational zero theorem to identify all possible rational zeros of a polynomial function. The word possible is very important because the rational zero theorem doesn't mean that every single one of the numbers that we're going to come up with is going to be a 0. It just means that it is a possibility that it is a 0. So that's something that's very important that I need you guys to take from today's lesson. The next objective is to be able to say, I can use my graphing calculator to identify a rational zero to help me to solve polynomial equations. So because this lesson requires a graphing calculator, I'm going to reserve one of the problems that we do today for class. So this lesson will be a little bit shorter as a result. So the rational zero theorem goes like this. What if the problem doesn't give us a 0? So in all of the problems that we've had so far, they have told us, hey, the number 2 is a 0. Find all of the other rational zeros. This time around, you're going to receive nothing. You're just going to receive a polynomial function. And the question is, what if we don't know a factor of the polynomial function? What if we don't know a 0? Where would we start looking for possible zeros? Well, that's where the rational zero theorem comes in. So the rational zero theorem says that if you have a polynomial function that has integer coefficients, then every possible rational zero that we call the PRZ, possible rational zero, every possible rational zero of that function has the form of P over Q. And what P means is the factors of your last term, your last number, which is your constant term, divided by the factors of the leading coefficient. Which is your first number. Assuming, of course, that your polynomial function is written in standard form. So I know what I just said there is weird. So P over Q means the factors. So we're going to identify all of our factors. So factors means what times what will equal that number. So it's going to be a bunch of fractions that will be the factors of your last number divided by the factors of your first number, your leading coefficient. So in an example in letter A, it's asking you to find the possible rational zeros. These are all of the possible numbers that could be x-intercepts. The key word here is could be x-intercepts. So possible means could be x-intercepts. Doesn't mean that they actually are. I cannot stress that enough. So our p-value represents all of our factors of our last number. So our last number, so it's the factors of the last number, or our constant term, and that is the number 6. So all of the factors of 6 are a plus or minus 1, a plus or minus 2, a plus or minus 3, and a plus or minus 6. You have to have a plus or minus because of the fact that we have to take into consideration that our possible rational zeros could be negative numbers. And so I know that 1 times 6 is 6 and 2 times 3 is 6. So I just listed all of my all of my factors of 6. This is going to be divided by all of my factors of my leading coefficient. And what's cool about this is that my leading coefficient is just the number 1. So it only has one set of factors, which are 1. Now what we're going to do is we're going to divide every single numerator by every single denominator, and that's going to represent our possible rational zeros. So I'm going to divide 1 over 1, which is a plus or minus 1. Every single one of these numbers will have a plus or minus in front of it. 2 over 1 is 2, so plus or minus 2. 3 over 1 is 3, plus or minus 3. 6 over 1 is 6, plus or minus 6. So all of these numbers are possible rational zeros for this polynomial. Let's go ahead and look at letter B. For letter B, it's a little bit different because our leading coefficient is something other than 1. So I have my P's over Q's, and I'm going to list all of my factors of the number 8. So the number 8 has a 1 as a factor, the number 2 is a factor, the number 4 is a factor, and the number 8. So I'm going to write plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. The number 2 has 2 factors, plus or minus 1 and plus or minus 2. So now I'm going to divide every numerator by every single denominator. And I'm going to have my list where I'm not going to write down any repeats. So I'm going to write possible rational zeros. So 1 over 1 is 1, so plus or minus 1. 1 over 2 is plus or minus 1/2. 2 over 1 is plus or minus 2. And 2 over 2 is plus or minus 1. I already wrote that down, so I'm not going to write it down again. 4 over 1 is plus or minus 4. 4 over 2 is plus or minus 2. I've already wrote that down, so I'm not going to write it down again. 8 over 1 is plus or minus 8, and 8 over 2 is plus or minus 4, which I've already wrote that down, and so I am finished. These are all of my possible rational zeros. These are all numbers that could potentially be x-intercepts of this function. It doesn't mean that it actually is. These are possible. So please note these are possible. If I have not stressed enough already, I'm just going to stress it over and over again that these are possible zeros. They aren't guaranteed to be zeros. So how could we find which, if any, are actual zeros? Well, you would have to test every single one using synthetic division until you found one that actually works. So you would do synthetic division over and over and over again until you finally got a remainder of 0. And back in the day when I was in high school, we used to have to do that. I would get my list of possible rational zeros, and I'd start with the number 1, and I would do synthetic division over and over and over again until I found one that worked. I would try positive 1, I tried negative 1, I tried positive 1/2, I tried negative 1/2. And it took a long time, especially if the only possible rational zero was the number 8. And that's a ton of synthetic divisions. So thank goodness for technology, because now I'm going to let you use your graphing calculator to identify a rational zero to start. Now remember that the word is rational zero, so that means that you can work with fractions or you can work with whole numbers. So like I said, in the old days, we had to test every one until we found one that worked. We, however, will allow you to use a graphing calculator to get you started. We will find the reasonable rational zeros, the RRZ, by using our graphing calculator, and we're going to test those. So we're going to have RRZs, so that's going to be an actual, a reasonable rational zero. Reasonable means that it's a fraction or integer. I'm going to zoom this in. A reasonable rational zero using our graphing calculator. So, all right, what we're going to do is I'm going to take out my graphing calculator, and I'm going to start. Before I do that, let me take 10 steps back. Before I do that, I want to find all of my rational zeros of this function. Notice that this function has 4 terms. What we have already learned is that if we see a function with 4 terms, then that means that we do factoring by grouping. So what I'm going to do on a note card is I'm going to show you that factoring by grouping does not work. So I have 0 is equal to x cubed minus 4x squared minus 15x plus 18. I'm going to put parentheses around the first 2 terms and parentheses around the last 2 terms. And these 2 terms have in common an x squared, but our leftovers is an x minus 4. Plus, I'm going to factor out a negative 3, because that's what 15 and 18 have in common, and my leftovers is an x minus 6. These 2 parentheses are not the same, so that means that this function is not factorable in the way that it is written. So that means that I have to do this approach. I have to identify my possible rational zeros. That is first. So my possible rational zeros. What's cool about this is that my leading coefficient is a 1, so I'm just going to list all of the factors of 18. So that's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Like I said, back in the day, you would have to test every single one until you found one that worked. But now what I'm going to do is I'm going to put this function into my graphing calculator, and I'm going to find a reasonable rational zero, a number that actually worked. So I'm going to put into my calculator the function x to the 3rd power minus 4x squared minus 15x plus 18. If you have a graphing calculator, I encourage you to do the exact same thing that I'm doing right now. Next, I'm going to press Zoom 6 so I have a standard window. And although I don't need to see what this whole function looks like, what's really cool is that I can see where my x-axis is. And what I'm going to do is I'm going to locate an x-intercept that I think could work. You want to try to find one that is crossing looks like it's crossing over an exact line. So I'm going to press second trace, and I'm going to go down to number 2, which is 0. And I'm going to identify this x-intercept, if I can. Oh, there it is. So looking at my blinking bug, oh, okay. If I go to the right, it's above, and if I go to the left, it's below. So I'm going to say that this is my left bound, enter. I'm going to press the right arrow 1 time. I'm going to press enter, and then enter again. and there's my rational zero. So I just identified an x-intercept. All you need is 1. So my x-intercept is located at -3, and that comes from the parentheses x plus 3. And that's going to come in handy a little bit later. But in the meantime, I'm going to use that -3 inside of the little box, and I'm going to use synthetic division for me to change this cubic to a quadratic. So I'm going to write down 1, -4, -15, and 18. I'm going to bring down the 1, and -3 times 1 is -3. -4 minus 3 is -7. -3 times -7 is 21. -15 plus 21 is 6. -3 times 6 is -18. And 18 minus 18 is 0, which is awesome. That means that I identified a rational 0 correctly because I ended up with a remainder of 0. So now I have an x plus 3. That came from what we started with. And now I have an x squared minus 7x plus 6, and this is equal to 0. You must have an equal 0, because we are finding our zeros. We're finding our x-intercepts. So now I'm going to write x plus 3 times 2 parentheses, breaking this quadratic down into 2 parentheses. I'm going to split apart the x squared into an x and an x. And I have to figure out what two numbers multiply to equal 6, but together add to equal -7. And that's going to be -6 and -1, so -6 and -1. So all of my zeros are x equals -3, +6, and +1. I'm just taking the opposite of what I see inside of each parenthesis, and that is my answer. -3, 6, and 1. Those are my x-intercepts and all of my zeros. I'm going to do letter B with you guys in class. If you would like to do it on your own, please feel free to do so. I have absolutely no problem with you doing that. All right, let's go ahead and flip the page. We have 2 more examples for this lesson. Here's example number 3. For example number 3, we have x cubed minus 5x squared plus 7x minus 35. So what I'm going to do is I'm going to write this down because it has 4 terms, and I'm going to see if I can factor it by grouping. So I have x cubed minus 5x squared plus 7x minus 35. I'm going to put parentheses around the first 2 terms and parentheses around the last 2 terms. X cubed and 5x squared have in common an x squared, with my leftovers being x minus 5. Plus 7 and 35 have in common a 7, and my leftovers is an x minus 5. Whoa, I ended up with both of my parentheses being the exact same. So that tells me I can do factoring by grouping here. So I'm just going to rewrite both of these steps right here into my notes. So I put parentheses around the first 2 terms and parentheses around the last 2 terms, changing this f of x to an equal 0. I'm going to factor out an x squared to make that x squared times x minus 5 plus 7 and 35 have in common a 7. So I'm going to factor out a 7, and my leftovers is x plus 5. So now I'm going to write 0 is equal to my outsiders, which that's an x squared and a plus 7. And my insiders, that's an x plus 5. I'm sorry, an x minus 5. Now that it's completely factored, I'm going to set each part equal to 0. So I have x squared plus 7 equal to 0, and I have x minus 5 equal to 0. We want real zeros. And so when I subtract 7 on both sides, I end up with x squared is equal to -7. And when I take the square root of both sides, I end up with x is equal to plus or minus I square roots of 7. And that is not real, and I only want my real solutions. Over here, I'm going to add 5 to both sides, and I find that x is equal to 5. And so that is my only solution. I have one more problem, and that is letter D. Letter D is different. Notice that letter D is a quartic function. It also has 5 terms in it, which means that you cannot use factoring by grouping. Also, because it is quartic, when we do synthetic division, that means that our result is going to be 1 degree less, and that means it's going to be a cubic. We can't necessarily factor cubics in the way that we would necessarily want, so you would have to do synthetic division again. So whenever you see a quark tick, the first thing I want you to know is that you're going to need two reasonable rational zeros because you're going to do synthetic division twice. Please note that factoring by grouping will not work in this problem. There are just too many terms. So what I'm going to do is I'm going to put this function into my calculator, and I'm going to rewrite this as 0 is equal to x to the 4th plus x to the 3rd minus 3x squared minus 5x minus 2. And I'm going to identify my possible rational zeros, which is the exact same thing as what I did before. So my factors of my last term are 2, and my leading coefficient is 1, so I only have plus or minus 1 or plus or minus 2 as my reasonable or possible rational zeros. So now I'm going to identify my reasonable rational zeros using my graphing calculator. And like I said, you're going to need 2. All right, so I'm going to go into my graphing calculator, and I'm going to enter in x to the 4th power plus x to the 3rd minus 3x squared minus 5x minus 2. From here, I'm going to press zoom 6 so I have a standard screen. And I'm going to identify 2 rational zeros. So I'm going to press second trace, and I'm going to go down to number 2, which is 0. And I'm going to move my cursor so it's just to the left of my x-intercept. I'm going to press enter, and then I'm going to press right, enter, enter. Let me try that again. Okay, let me see if I can do a better job. Let's try this. Enter, enter, enter. There we go. I end up with negative 0.9 repeating, essentially. So if I were to round that number, that would essentially be negative 1. So I'm going to use x equals negative 1. And that comes from the parentheses x plus 1. But I need 2 rational zeros, so I'm going to find what this 0 is over here. So I'm going to press second trace, go down to number 2. And it looks like this is the left side, enter. Here's the right side, enter, enter. And that is at 2, 0. So then I have x equals 2, and that comes from x minus 2, that parenthesis. All right, I'm going to work with x equals negative 1 first, but before I do that, let me make sure that you guys are all on the same page with me. So whenever you have a quartic function, you must have 2 reasonable rational zeros because you will need to do synthetic division twice. Since we have a degree that is equal to 4. So synthetic division twice will reduce the function to a quadratic. That could be factorable. All right, here we go. The first thing I'm going to do is I'm going to work with negative 1, and I'm going to do synthetic division using my original problem. So I have 1, 1, negative 3, negative 5, and negative 2. I'm going to bring down the 1. Negative 1 times 1 is negative 1. 1 minus 1 is 0. Negative 1 times 0 is 0. Negative 3 minus 0 is negative 3. Negative 1 times negative 3 is 3, and negative 5 plus 3 is negative 2. Negative 1 times negative 2, that's equal to 2, and negative 2 plus 2 is 0. So now what I have currently is I have an x plus 1 times an x cubed plus 0x squared minus 3x minus 3 is equal to 0. So I'm going to have to factor this even further. So now I'm going to use my other 0, which is x equals 2, and I'm going to factor or use synthetic division again. And since I've already used the negative 1, I'm going to use my other 0. So I'm going to use, I'm going to write 2 right here, and I'm going to write 1. I'm running out of space. How about I do right here? Put 2, and I'll write 1, 0, negative 3, negative 3. All right, bringing this down. Bringing down the 1, 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 3 plus 4 is 1. 2 times 1 is 2. Hold on. Oh, I forgot the minus 2. Hold on. Make this minus 2. Make this a 2. 2 minus 2 is, I forgot the minus 2 right here. Sorry, I wrote down a negative 3 on accident. This was supposed to be minus 2. So negative 2 plus 2, that is 0. Sorry about that, guys. Okay, so this is where I'm at. So now I have an x plus 1 we already used. So I'm going to still keep it because it's still part of our answer. I have an x minus 2, and now I have an x squared plus 2x plus 1 equals 0. Now this is something I can try to factor. So I'm going to write x plus 1 times an x minus 2 times 2 parentheses equal to 0. Splitting apart the x squared into an x and an x, I have to ask myself, what two numbers multiply to equal 1 but together add to equal 2? And that is a plus 1 and a plus 1. So our final answer is going to be, our rational zeros are 1 and 2 because technically this is x plus 1 cubed times x minus 2 is equal to 0. X equals 1 or x equals 2. And that is our answer, as well as the end of this video. So I'm so sorry about this. I just screwed that up. I wrote that as a 3 instead of a 2, but the final result should be the same. And that is the end of this lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.